Hey everyone, and welcome back to Talk Tensors. We're diving deep today into a paper that's making some serious waves in the AI and dentistry world.
Oh, yeah. It's a fascinating one.
It's called SharNet, Conditioned Heat Map Regression for Robust Dental Landmark Localization.
It's quite a mouthful.
Yeah, but I think the title itself kind of hints at the complexity of what they're trying to achieve here.
It really does.
So the listeners might be thinking, teeth on a machine learning podcast.
Right, like what's the connection?
But this paper really highlights how AI is beginning to make its mark on all sorts of specialized fields.
Yeah, dentistry is no exception.
And this problem they're tackling, accurately detecting landmarks on these 3D dental models, it's tougher than it sounds.
It's surprisingly complex.
So let's break it down. Why is landmark detection such a big deal in dentistry?
Well, think about it. Accurate landmark placement, that's the foundation for so many procedures, especially as dentistry becomes more and more digital.
Right, like if you're getting braces.
Exactly. The orthodontist needs to know exactly where to put those brackets to make sure your teeth move the right way.
And I imagine doing that manually can be really time-consuming and prone to error.
You nailed it. And that's where AI steps in. That's where this paper introduces SharNet.
This AI system designed to automate that landmark detection on those 3D models.
Yep. And what's really cool here is that SharNet doesn't need each tooth to be segmented first, which was a big hurdle for the older methods.
So the AI is seeing the whole picture, the whole dental arch, instead of getting stuck on identifying each individual tooth.
Precisely. It's this end-to-end approach, taking that 3D scan and directly detecting the landmarks.
And it uses heat map regression to do this.
Yeah. Have you heard about that one before?
I have, but maybe just a quick refresher.
Basically, the AI is trained to predict how likely it is that each point on that scan is a landmark.
So it's creating like a probability map, the hot spots, showing the most likely location of each landmark.
Exactly.
Interesting. So it's not just saying, here's the landmark. It's more like saying, I'm pretty sure it's somewhere in this area.
Yeah.
But then what about when someone's missing a tooth?
Uh-oh.
Doesn't that throw everything off?
That's a great question, and that's where things get even more interesting.
Okay, tell me more.
The researchers really tackled this head-on.
Wow.
They developed this module called SharR, that's CHAR, which stands for Conditioned Heat Map Regression.
Okay, I'm following so far. So what does this SharR module do?
It basically uses a null point as a stand-in for the landmark of any missing tooth.
Oh, that's smart.
So the AI can still make predictions without getting confused by those gaps in the data.
So the AI is like, okay, I know this tooth is missing. I'll adjust my predictions accordingly. But how does it even know which teeth are missing in the first place?
Good question. They built this separate classification head right into SharNet, specifically to pick out which teeth are there and which aren't from the scan.
So it's analyzing the scan, figuring out which teeth are present, and using that to fine-tune its landmark predictions. Exactly. It's almost like the AI understands dental anatomy, right?
It's a great way to put it. It's not just randomly placing dots on the scan. It's considering the context, the structure of the dental arch.
That's pretty impressive. Now, to train this AI, they must have needed a ton of data, right?
Oh, yeah, absolutely. They actually created a whole new data set.
Oh, wow.
Over 1,200 annotated 3D dental models.
That's a lot of teeth.
It is, and it's a huge contribution to the field because it's so diverse. Models with missing teeth, third molars, all kinds of variations.
Like they wanted to train this AI on real-world data, right?
Exactly. You don't want to train an AI on just perfect teeth and then have it fail in the real world.
Right.
Where people have all sorts of dental histories.
Yeah, so how did SharNet actually perform? Did it pass the test?
Well, they used two key metrics, mean Euclidean distance error, or MEDE, and mean success ratio, or MSR.
Okay. Gotta love those acronyms.
Right. So MEDE basically measures the average distance between where the AI placed the landmark and where it actually is.
So the lower the MEDE, the better, the more accurate.
Exactly. And then MSR, that's the percentage of landmarks the AI placed within an acceptable range of the real location.
Got it. So higher MSR is better there.
Obviously.
And drum roll, please. How did SharNet do?
The results were really impressive on those complete models. SharNet got a MEDE of just 0.51 millimeters.
Wow, that's tiny.
It is. And even across all the models, including those with missing teeth, the average was 1.28 millimeters.
Still pretty impressive.
Oh, yeah. And the MSR was high, too, over 87% on complete models and over 82% on all models.
That's pretty amazing considering how much variation there is in dental structures.
Yeah, it's really quite remarkable.
But before we get too carried away with the results, I'm curious about the tech behind it all.
Right, under the hood.
What's driving this SharNet system?
So at its core, SharNet uses a neural network designed specifically for for point cloud data. Remember those 3D scans we talked about?
Yeah.
Well, they're represented as point clouds, basically collections of individual points with their coordinates in 3D space.
So instead of a solid image, the AI is working with this collection of points that map out the shape.
Exactly, like a digital connected dots, but in 3 dimensions.
And the specific type of network they use is called Point MLP.
Have you heard of that one?
Yeah, Point MLP rings a bell. Maybe we've touched on it before, but I'd love to get a little deeper into how it works in this context.
Yeah, it's really fascinating. Point MLP, it's known for being efficient, and it's great at extracting meaningful features from point cloud data, even when there are irregularities or gaps.
Makes sense considering those null points they use for the missing teeth.
Right. But SharNet isn't the only AI using point cloud data. There are other approaches out there.
Oh, so it's like a point cloud showdown.
Kinda. The researchers actually compared SharNet to some other cutting-edge methods.
Okay, which ones did they throw into the ring?
Well, they included PointNet Plus, PlusLay, DDCNN, Point Transformer, Point Next, all the big names.
So how did SharNet stack up against the competition?
The results were pretty convincing. Across the board, SharNet, especially with that SharR module, it showed better accuracy and robustness, especially when dealing with those missing teeth.
Sounds like SharR is really the star of the show here.
It's a game changer for sure.
But before we get too deep into the technical details, I think it's worth stepping back and looking at the bigger picture.
Yeah, zoom out a bit.
We've talked about how this AI could revolutionize orthodontics. But what about its impact on other areas of dentistry?
Right, because accurate landmark detection, that's key for a lot of procedures.
Exactly. It's not just about braces.
This is where it gets really exciting because the technology has a lot of broader applications.
Okay, like what?
Imagine using it for dental implants, crowns, bridges, even surgical planning.
Well, hold on. That's a lot to process. Let's break it down. Starting with implants, how could SharNet be useful there?
Okay, well, with implants, you need to know exactly where to put that implant post in the jawbone.
Right.
And that requires really precise measurements, pinpoint accuracy with the landmarks. SharNet could help automate that whole process, making it faster, more accurate, and maybe even less invasive for the patient.
Got it. And then what about crowns and bridges?
Well, there you need to make sure you get a perfect fit.
Yeah, so they don't fall out.
Exactly. The AI could help create those digital models that are super precise, so the crown or bridge just fits perfectly and functions the way it should.
And surgical planning, that feels like a whole other level.
It is, but that's also where the potential benefits of AI are huge.
Yeah.
Imagine using SharNet to create these 3D models that guide the surgeon during really complex procedures.
Like an AI roadmap for surgery.
Yeah, helping to improve accuracy and minimize risks.
This is starting to feel like something straight out of a sci-fi movie. It's amazing. But it also raises a really important question.
What's that?
What about the role of the dentist in all this?
That's crucial to remember. AI is a tool. It's not a replacement for human expertise.
Right. Dentists aren't going to be out of a job anytime soon.
No way. Their knowledge, their experience, their judgment, that's always going to be essential.
So it's more about augmenting their abilities, giving them a powerful new set of tools to work with.
Exactly. It's a collaboration between human intelligence and artificial intelligence, working together to achieve better outcomes for the patient.
That's a great way to put it. But as with any new technology, there are going to be challenges.
For sure.
What are some of the potential hurdles that need to be overcome before this becomes standard in dental practices?
Well, one thing is standardization. Right now, there are so many different 3D scanning systems and software platforms used in dentistry.
Right. Everyone's got their own thing.
Yeah, so for SharNet to be widely adopted, there needs to be some level of standardization to make sure everything's compatible.
Makes sense. And then there's the issue of training, right? Dentists will need to learn how to actually use these AI tools effectively.
Absolutely. Integrating AI into the dental curriculum, that's going to be essential.
Yeah.
Dentists need to understand what these systems can do, what they can't do, how to interpret the results.
And of course, there's the cost factor. These advanced AI systems don't come cheap.
True, the initial investment can be a lot, but you have to weigh that against the long-term benefit.
Right, like increased efficiency, accuracy, maybe even lower costs over time.
It's like any big tech shift. There are growing pains. But if the benefits are substantial enough, it usually finds its way into mainstream practice.
This has been a really fascinating deep dive into AI-powered dentistry. It's amazing to see how tech like SharNet is already making an impact in specialized fields.
I completely agree. And what's even more exciting is that this is just the beginning. As AI keeps evolving, we can expect even more innovative applications in dentistry and beyond.
Speaking innovation, before we wrap up part one, got to tease our listeners with a glimpse into our novel notions segment,
Yeah.
where we'll explore some of the, shall we say, more out there but still plausible ideas inspired by this research.
Just my favorite part.
I've got a feeling you've got some really wild ones cooked up.
I've got a couple I'm excited to share.
Okay, I can't wait to hear them. But for now, we'll leave our listeners hanging and encourage them to come back for part two of this deep dive.
In part two, we'll get into the nitty-gritty of SharNet, break down how Point MLP works, and we'll also take a look back at the history of landmark detection in dentistry.
How'd we get here?
The evolution of the field, and how AI is poised to really revolutionize it.
So stay tuned for part two, where we'll unpack even more fascinating insights from this groundbreaking paper.
It's going to be good.
See you there.
Welcome back to Talk Tensors. Last time we were talking about all the cool things AI could do in dentistry, like implants and even surgery.
Yeah, it was kind of mind-blowing to think about how AI could help create these really precise models and maybe even change the way dental procedures are done.
It really is amazing.
But I'm also really interested in getting a little more technical.
Yeah, let's dig in.
We briefly talked about Point MLP, the neural network behind SharNet. Can we break that down a bit more?
Absolutely. Point MLP, it's like the engine of the whole system. Remember, we're dealing with these 3D scans represented as point clouds?
Right, those collections of points in space.
Exactly. And Point MLP is designed specifically to handle this kind of data. What's interesting is that it's built using multilayer perceptrons, or MLPs.
MLPs.
Yeah, which are actually a pretty simple type of neural network, kind of classic.
I'm surprised something so classic is being used for such cutting-edge research.
It really shows how powerful these fundamental AI building blocks can be. Sometimes the simplest approach is the best one. So what Point MLP does is it takes the point cloud data and processes it through these layers. Each layer has these MLPs in it.
Okay.
And as the data flows through these layers, the network learns to pick out more and more complex features and patterns.
So it's like starting with a basic understanding of the individual points and then building up this more sophisticated picture of the whole structure.
Exactly. And it does this by looking at the relationships between the points in space, kind of like how our brains understand depth and how things are arranged.
Well, that's interesting.
It's not just looking at each point on its own, it's thinking about how they all fit together.
So what makes Point MLP better for this task than other types of neural networks?
Well, one big advantage is that it's really efficient.
Okay.
It doesn't need those complex convolutions or other operations that can really slow things down, like some other point cloud models use.
Right, that makes sense.
This makes it faster and more scalable, which is really important for real-world applications.
Especially in a clinical setting where time is precious.
Exactly. Every second counts.
But how does this Point MLP architecture work with the SharR module, that part that deals with missing teeth?
Okay, so after Point MLP extracts those features from the point cloud, the information gets sent to two parallel branches, kind of like a fork in the road.
Two paths.
One branch focuses on landmark regression, basically predicting where those landmarks are based on what it's learned.
Okay, so that's where those heat maps come in, those probability maps, highlighting the likely spots for each landmark.
Exactly. But here's the thing. While that's happening, the other branch is working at the same time, classifying whether each tooth is present or absent in the model.
So it's like a double-check system. The AI is making those landmark predictions, but it's also figuring out if any teeth are missing.
Yep, and that's where the SharR module steps in.
Okay.
It takes the output from both branches, the landmark predictions and the tooth classifications, and uses that information to fine-tune the final predictions.
So if a tooth is missing, the SharR module says, hold on, we got to adjust those landmarks.
Exactly. It uses those null points as placeholders for the missing teeth and makes sure the predictions fit the overall dental structure.
It's almost like the AI is saying, something's missing here. Let me adjust my calculations.
It really is remarkable. It shows how AI is going beyond just crunching numbers and actually starting to understand the underlying structure.
It's pretty impressive, but I'm also curious about the historical side of things. Landmark detection in dentistry has been around for a while, right?
Oh, yeah, definitely. It's not a new concept. Dentists have been doing this manually for decades, using tools like calipers.
That sounds so tedious.
It was, and of course, prone to human error. But then as technology advanced, we saw the introduction of computer-aided design and manufacturing systems, CAD/CAM systems.
Right, those systems that use digital scanners and software to create the 3D models.
Exactly. And once we had 3D imaging, there was a big push to automate landmark detection.
Makes sense.
Early attempts used algorithms based on image processing techniques.
But I imagine those had limitations, especially with all the complexities of real teeth.
Yeah, they often struggled with variations in tooth shape, how the teeth fit together, and of course, missing teeth.
So that's where AI and deep learning really shine.
Exactly. AI methods like SharNet can handle those complexities much better. They learn these intricate patterns from tons of data, making them more robust and accurate.
It's amazing to see how far we've come, from manual measurements to these AI systems that can analyze 3D models and make precise predictions.
It's really remarkable.
It shows how technology is changing healthcare in such a big way.
Absolutely. And the exciting thing about AI is that it's always evolving. As we get more data and develop smarter algorithms, the possibilities are endless.
Speaking of possibilities, I'm really eager to hear those novel notions you mentioned earlier, ready to jump into those.
Let's do it. Let's get creative and explore some potential future directions inspired by this research. One thing I've been thinking about is this idea of a dental AI assistant.
Okay, a dental AI assistant, I'm listening.
Imagine a personalized AI system that not only helps dentists with tasks like landmark detection, but also gives them real-time guidance during procedures.
Like an AI co-pilot for the dentist.
Exactly. The AI could analyze the patient's 3D model, spot potential problems, and even suggest the best way to approach the procedure based on its knowledge base.
That'd be incredible. It could really help dentists make better decisions and potentially lead to better outcomes for patients.
That's the goal, and it could also be used for training. Imagine dental students practicing in a virtual environment with guidance from this expert AI system.
That's a fantastic idea. It could revolutionize dental education.
And help make sure future dentists are comfortable using these AI tools.
It's really exciting to think about the possibilities, but before we get too carried away with these novel notions, it's important to remember these are just ideas for now.
Of course.
There's still a lot of work to do to make them a reality.
Absolutely. But that's what makes this field so exciting. There's so much potential for innovation.
So much we don't know yet.
Who knows what amazing breakthroughs are just around the corner.
Well, on that note, I think it's time to wrap up part 2 of our deep dive.
Okay.
We've covered a lot, from the technical details of Point MLP to the history of landmark detection and even some glimpses into the future with those novel notions.
It's been a great discussion.
But we're not done yet. In part 3, we'll continue exploring those novel notions and dive even deeper into how AI could shape the future of dentistry.
I can't wait.
So stay tuned for the final part of this deep dive, where we'll explore even more groundbreaking ideas and try to picture what AI-powered dentistry might look like in the future. Welcome back to Talk Tensors for the final part of our deep dive into AI-powered dentistry.
I'm glad we could continue our exploration of those novel notions.
Yeah, those thought experiments, those brainstorming sessions.
Yeah, those intriguing ideas based on the SharNet research.
Right, we were just starting to imagine what a dental AI assistant could look like.
A digital helper for dentists.
Yeah, providing real-time guidance during those procedures and even revolutionizing how dentistry is taught.
And that's really just scratching the surface.
I bet you've got more.
I've been giving a lot of thought to how AI could really transform the patient experience.
Okay, I'm all ears.
Especially when it comes to something I think a lot of people dread, dental anxiety.
Oh yeah, I can relate to that. I think most people get at least a little anxious about going to the dentist.
For sure. For some people, it's a huge barrier to even getting the care they need.
That makes sense.
What if we could use AI to make the whole experience more calming, more personalized?
Now that would be a game changer. How would that even work?
Just imagine a dental office that's equipped with AI systems that can sense and respond to a patient's anxiety levels in real time.
Okay, that sounds super futuristic. How could the AI even tell if someone's anxious?
There are a lot of possibilities. We could use wearable sensors to track things like heart rate and skin conductance.
Right, those little physiological changes that give away our anxiety, even if we're trying to play it cool.
Exactly. But we could also use computer vision to analyze facial expressions and body language.
So the AI would be looking for those telltale signs, like fidgeting or a tense jaw.
Yep, picking up on those subtle cues, and then based on what the AI detects, it could trigger different things to help the patient relax.
Like what? Are we talking soothing music or nature sounds?
Those could definitely be part of it, but we could go even further.
Okay, I like where this is going.
Imagine the AI adjusting the lighting in the room, diffusing calming scents, or even projecting personalized images that the patient finds relaxing.
Wow, that's like a totally customized sensory experience. It's like having a spa day at the dentist.
Exactly. And here's another idea. What if the AI could create personalized educational content that addresses the patient's specific worries?
So if someone's nervous about a particular procedure, The AI could provide information and visuals that are tailored to them.
Exactly. Walk them through the steps, explain the benefits, maybe even show examples of successful outcomes.
That could be so helpful for patients. Knowledge is power, especially when it comes to something that makes you anxious.
It really can make a difference, and by addressing those anxieties directly, we could create a much more positive, maybe even enjoyable dental experience.
Wow, it's amazing to think about how AI could transform something that's usually associated with fear and discomfort into something more pleasant.
It's about changing the whole mindset around dental care.
And this is just one example of how AI can be used to personalize healthcare, to really cater to each patient's needs.
It's like precision medicine, but for the entire patient experience.
That's a great way to put it, but we can't forget about the ethical side of things.
You're right, that's crucial.
When we're talking about AI in healthcare, we have to be really careful about potential biases.
We need to be sure these systems are used responsibly.
Absolutely. We don't want AI systems that make existing health disparities worse or discriminate against certain groups of patients.
You need to be very thoughtful about how these technologies are developed and used to ensure they benefit everyone.
Well, this has been an amazing deep dive into AI-powered dentistry. We've explored so much,
We really have.
from the technical details of SharNet to the broader implications and potential applications of AI in this field.
It's been a fascinating conversation, and I hope our listeners are as excited about the potential of AI in healthcare as we are.
It's clear that AI has the potential to completely revolutionize dentistry.
From making procedures more accurate and efficient to creating a more personalized and positive experience for patients.
And while there are definitely challenges, I'm really optimistic about what the future holds for AI in dentistry.
Me too. It's such an exciting time to be following this technological revolution.
And if any of our novel notions sparked your imagination, we encourage you to keep exploring those possibilities, maybe even contribute to the development of these groundbreaking technologies.
There's so much room for innovation.
Thank you for joining us on this episode of Talk Tensors. We'll be back soon with another deep dive into the cutting edge of AI research.
Until then, stay curious, keep learning, and let's all embrace the potential of AI to shape a better future.